Now today we are going to highlight a few points related to coefficient of variation and variance. This coefficient of variation and variance, both of things we have already done it in detail. We know for what purpose they are, but quickly little bit revision of coefficient of variation of the same example which I discussed in the previous class. We know that what are the formula for coefficient of variation? That is for population, it is sigma by mu multiplied by 100%, and for sample, that is standard deviation divided by sample mean multiplied by 100. So today we are going to, and we also know that coefficient of variation is a relative measure, and it is highly useful for computing the variability between two different distributions. But why we are I am talking of these two formulas, that this will continue up to the variance also. Let's see that standard this example which we have done it, that price of movie tickets in different cinema halls of two different countries, that is India and US. So in India it is the rupees, and US is in a dollar, and within that we have seen that we have computed mean of India is 550 and mean in the US is $11. Similarly variance and then standard deviation. And we also seen that if we are try to compare on the basis of mean, variance and standard deviation, we take a variance that is valuable, again multiply double of that. So this 3 is not nice enough to compare the two different frequency distribution, or you can two frequency distribution with different units, one can say. So there are two different units. That is the main issue. So that's what we are using coefficient of variation, and coefficient of variation is a unit free. So the best part of coefficient of variation is it does not have any units for measurement. That's how we are able to compare dollar with rupees. And for comparison purposes, the coefficient of variation is one of the best which we can use it. And this we can also term as a relative standard deviation. And it also gives it some sense of direction. If coefficient of variation is greater than 0, then two variable moves in same direction. If coefficient of variation is equal to 0, then two variables are independent. If coefficient of variation less than 0, then two variables move in opposite direction. So we immediately can come to know that how the relation between the two variables which we are measuring it and which are being measured in two different units. So that's how that basic job of coefficient of variation, with small portion which we left in our previous discussion. So I thought that it should also be added into that. And the next is the variance, and we know that variance also one of the very good measurement for the variability. Again, one thing if you remember, when we are talking of, I am only talking today ungrouped data, the same thing also applicable for group frequency data. And here the formulas are population variance and sample variance. But here in the sample variance, we are using n-1. N is a sample subset of capital N. So, but why n-1? We have told you that there is one reason, but that reason we are not going to discuss today. But its impact is entirely different now in our calculation. That today we are going to elaborate. That is how this n-1 plays a role. How the sample data, if you just see the formula of population mean and sample mean, the formula is same. That is capital N, and for sample it is small n. That is the difference. But here it is n-1. It means one observation is deducted. So what's its impact? That we are going to see. And we know that variance is a measure of dispersion of a set of data points around their mean. All the values are supposed to vary around the mean. And dispersion is non-negative, and non-negative values don't cancel out, because standard deviation, you have seen that we some values are cancelling each other, but when we scale it, the variance, so all value become positive. So when all value become positive, so the effect becomes very high. So if we 10 square is 100, if there is a lower result, but higher result, if you take 100 square, that is 10,000. So that is the impact of dispersion. When variance is taking the square root of the values. But in the formula, we have seen the difference between the two. So that formula now we are going to say, I am going to show you what is the impact of that. Let's take, this is the population 10, 20, 30, 40, 50. Only this is a small population. So what is the mean of this? Very simple. Mean is 30. Next is, we computed population variance. We are taking as a population variance. So population variance works out to be 200 by using that formula. But now for the same data, if I treat that this data is a sample, once I said population, now I say it is a sample. So I'm using a formula for sample variance. So it works out to be 250. So why sample variance is greater than population variance? That is important. Because we have done n minus 1, we have removed that, we are always taking the above values. That's why it is sample variance is always be greater than population variance. Let's take another example also. If the data is this, now we have simply repeated values. Here we have repeated some values. Here we have repeated some values. So mean is 32. See, data is approximately same, but repeated value. Sample size is increased. Population variance is 296 and sample variance is 328.889. So it is too big now. So sample variance is always be greater than population variance. So why? Because variance is calculated on the basis of whole data set. So that is a accurate. But in sample, the knowledge of population is not there. So it is a sense of some uncertainty. So that's showing you some sense of some uncertainty. So sample mean is behaving differently as from the population mean. So sample variance reflects higher potential of variability. That is the main crux of the today discussion. So sample variance, because there's some uncertainty is there, it means data variability is there. So that shows a higher potential of variability. So that's all for our discussion today. And I hope that small exercise, small example, I have to take it that to clarify whatsoever we have discussed in our previous session. Okay, thank you very much. Thanks a lot.